Hey guys, I'm back again with another video. This one is on financial maths and we're doing some more annuities. This is a follow-up question on the previous question I did on annuities. You can find it under financial math annuity 1. But yeah, let's go. At the end of the investment period, Patrick reinvested the full amount in order for him to be able to draw a monthly pension from the fund. He reinvested the money at an interest rate of 10% per annum compounded monthly. If he draws an amount of 30,000 Rand per month from this investment, for how many full months will he be able to receive 30,000 Rand? Okay, so firstly, what has been happening is that Patrick was over here and the investment account was over here, and he was pouring money, he was putting money into this account on a regular basis at 10,000 Rand for 9.5 years or 114 months. He's been doing that and he's managed to amass the amount of 1,600,000, let's check, 1,674,501 Rand and 44 cents. So this is the previous question, and we've seen that he's been investing. Here's the 10,000 Rand that he's been investing into the account. The interest rate was different. The interest rate was 7.72% per annum. It was also compounded monthly, and he's managed to gain that amount of money in the account. Okay, so now he wants to know, he wants to draw 30,000 Rand from this 1.67 million. He wants to draw 30,000 Rand a month, and he would like to know for how many months can he do this? How many full months can he do this for? Okay, so if we need to find some mathematical representation for what we want to do, and we have an equation which looks like this. It says P 1 minus 1 plus I over N minus NT. It's important that we remember the minus, divided by I over N. Okay, so what is this equation? This equation doesn't look nice. Just hold on. Yes, there we go. So this equation kind of does the reverse of the investments equation. If we look at the investments equation, we have a positive NT there, and when we are trying to withdraw money from the account in a pension fund style, we have minus NT. So that is the difference between the equation. Also, what we see is that in the investments equation, it's 1 plus I over N NT minus 1, and in the pension fund question, it's 1 minus 1 plus I over NT to the power of minus NT. Okay, so this is the equation that we're going to be using, and we have to get, what we want to find is the NT part of it, because this describes the time. There's the payments that is done, or that the withdrawal, in this case, the withdrawal that is done over there. There is the amount of money that's available in the fund over there. There's the number of number of times the interest rate is compounded. There's the interest rate. So all of it is there besides the time. We're just looking for the time. So let's take down what we have. The PV equals to 1,674,501.44. That's the PV. The P equals to 30,000. That's what we would like to draw per month. I is equal to R over 100, which equals to 10 over 100, and that's 0.1. Then N equals to, we want to compound this 12 times per month. Oh, sorry, 12 times per year, because there's 12 months per year. And we want to know the time. So what we can see here is they want the time in full months and not in years. So all we should do is find NT, because NT will give us the amount of months that we could withdraw 30,000 Rand from this account. Okay, so let's get into processing all of this. Where do we start? So we can see that the minus NT is covered in a lot of other operations that we first have to undo. There's a I over N here that we must resolve. There is a P here that we must resolve. There's a -1. So there's quite a few things that we need to get out of the way first before we can get to the minus NT. So how do we do that? We firstly start by the simplest, which is outside of the brackets. It's PV over P. That's where we start. We divide by P on both sides. That leaves us with 1 plus I over N to the minus NT. All of this over I over N. So we've seen that we managed to remove the brackets by dividing with P. Another thing that we want to do is we want to get rid of the I over N, so we multiply by I over N on both sides. So what we have is PV over P times I over N, and that gives us 1 minus 1 plus I over N, all to the power of minus NT. We are getting closer to the NT. So what we are going to do right now is that we are going to add 1 plus I over N to the power of minus NT, and we are going to subtract PV over P times I over N. That is what we're going to do right now, and what this gives us is 1 plus I over N minus NT, 1 minus PV over P times I over N. Okay, so we are now at a point where we've separated most of the operations we've undone. There's one more thing that we need to do. What was it? 1 plus I over N, I over N to the power of minus NT equals to P, 1 minus PV over P I over N. We are multiplying these two with each other. Okay, yes, that's correct. Okay, so we now need to, the only way that we can solve this, or that we can get this out here, is by using log laws. So I know it's pretty daunting, but we're going to use one specific characteristic or one specific log law, and we're going to be using the one that says log of a to the power of k equals to k log a. Okay, so if we apply this, if we apply log to both sides, what we get is log of 1 plus I over N to the power of minus NT equals to log of 1 minus PV over P times I over N. Okay, so now once we took the log of both sides, we can apply this law, and we took out the K, so we can take out the NT. Minus NT, actually, sorry, the whole thing. Minus NT log of 1 plus I over N equals to log of 1 minus PV over P I over N. Okay, so now what's left to do is that we need to divide both sides by log of 1 plus IN, because we want this part right here. That's a bad arrow. We want this right here. We want the NT part, because we want to know how many months, and NT represents the months. Okay, so when we divide by log of 1 plus I over N on both sides, it looks like this. Let's do it on the next page. I've realized that I'm going to be running out of space. Or I'm running out of space. Okay, next page. Minus NT log of 1 plus I over N. Is that correct? Yes. You go equals to log of minus. No. 1 minus PV over PI over N. I think it's something like that. Okay. Minus NT, like we said, the plan was to divide by log of 1 plus I over N on both sides. Pi over N. All of this over log of 1 plus I over N. Okay, so once we put all these values in our calculator, and I mean we use scientific calculators and it's more than, yeah, once you put the values in your calculator, you see that minus NT equals to minus 75.3934, something like that. And this is months, remember, because of this part right here. 12 months per year, NT equals to the number of months. Okay. And then we don't like the negative there, so we can say NT equals to, when we multiply or divide both sides by minus 1, we have 75.3934 months. But they want to know how many full months. There are only 75 full months in 75.3934 months. Okay, so that is it. That is our answer. He gets to get paid his money just for interest's sake. How many years is that? Let's see, 75 divided by 12. That is 6.25 years. So he's invested for 9 at 10,000. He gets to withdraw for 30,000 rand for 6.25 years. It's an okay deal, I guess. Okay, so one of the things that we should be what should we be focusing on when we deal with problems like this? We should establish what they want. Firstly, they wanted how long he can withdraw, how many full months. Remember the full months part, because you get marks for saying 75 full months. And then we need to remember to use this equation. That's the second part. It's a pension fund or a diminishing equation, the pension fund equation. That's the second thing that we need to remember. And then there are going to be times, whenever we're dealing with powers, there are going to be times where we might have to use logarithms. So we need to know our log laws. This is mostly the one that will be used when we are dealing with powers. NT minus NT is a power, so solving NT you would need logarithms. And then, yeah. So we left with our answer at 6.25 years, and yeah. Thank you very much for watching. Goodbye.